Hello everyone and welcome to a new series on RPG core system. This is my second attempt to record this video because the first one I foolishly forgot to open my mic. Anyway, in this series I will start an RPG core system, and it's related to the series I'm recording and maybe uploading in between these series recording, related to a system based on Dungeons and Dragons RPG system. You can find those videos on brainstorming. But in the same time, I will use lots of stuff around the world that are available for free, and you can get them. One of them is the fundamental stuff from Peter's Hack and Slash RPG game tutorials. It was very nice system, had its flaws, but I'm not sure why Peter is not continuing it anyway. But in the same time, I will use some scripts that are available for free. I will use some assets that are available for free, and I will tweak lots of stuff on Peter's scripts later on. Now, what I have done before starting the series, I made a very simple level with just cubes and a capsule there. I imported lots of free animations that are available on Assets Store. The only one that is not free and it's paid is this guy for climbing the walls. Other than that, every one of them are free, and one of the interesting ones that if I can find is jump height. You can see it's jumping and climbing on edges. It's really nice. Okay. Other than that, I imported some free assets, some models that is empty, and sorry, free models, yeah. Some free models like this angelic sword. Wow, it's free, guys. Free from Asset Store. Asset Store, I love you. PLY Proto, just search it. It has nice stuff just to start your game uh, with some predefined basic characters that will help you. And what else do I have here? Oh yeah, in animation. Oh, I moved it out. Okay. So none of these will be available for you guys because I made a repository on GitHub, but honestly, these will be lots of space, and I don't think I can handle it there. But now, the scripts folder here, all of that will be available. So the first thing I want to get is this guy for free, FPS Walker Enhanced. It has a good description, JavaScript versions that I hate, a Boo version that I don't understand at all, but this is the one I want, C# version, okay? I will copy it, all of it, come on, come down, come down. Page down, page down, page down, okay. Here, copy. Then in my scripts, in character motor, I will create a new C# and I will call it RPG player motor. And here I think reload all. Yes. Come on, where is it? It should be under this guy. Ah, come on. Did you please sync? Reload all. Yeah, here it goes. So we have this guy. I will completely paste that one in here. Okay, and the only thing I need to change is the name, so it's RPG player motor. Okay, and on top of that I want add component menu, and that would be RPG player, character and player, then motor. Okay, now it's very good documented. I like it, but there are stuff that I don't like it. So I will add public string forward axis equals to horizontal with capital H, to be safe here, and replace it here. Then it happens every now and then. Okay, my screen got messed up. String strafe axis equals to B C, and paste it here. Then I have this tag, I will bypass it for time being, run. Okay, so here I will have public string run axis equals to run, and then public string jump axis equals to jump, and then public string sliding tag equals to slide. Okay, run axis. I use it once here, somewhere else, I remember, yeah, here. And the final one, jump axis. That is here. Okay. And that's it. Saving it. On my capsule, I will add a component, and I should, come on, components. Okay. Add component, RPG character player motor, and it adds the character controller for me. Now, things are a bit, I think, not nice here. I want toggle run, I want 3 here, and I want to have these. So I will change it here. Sliding speed equals 3, because 12 is suddenly sliding. It's not nice. This guy is true. This guy is true. And what else? Toggle run is true. Okay. Now, for demonstrating the abilities, I'll move my capsule. Come on, move. Yeah. Thank you. So on this slide, now the slide limit is coming from from my character controller slope limit. Okay. This slope is not 45. It's less than 45, but it's tagged as slide. And on my capsule, I said that, hey, slide untagged objects. Okay, as you can see. So If I play, my character will fall down and slide. Okay. If I uncheck this guy, it won't slide. Come on. You see, it won't slide. As soon as I tick it, it will slide. The other thing, limit diagonal speed, is when you hold forward and strafing at the same time and you don't want it to bypass the walk speed. Toggle run, I mapped the run to RT, so when I hit the R just once, I'm running. Okay, if I hit it again, I'm walking. If I choose to not toggle the run and I play, now if I walk, hit R and walk, I'm walking. Okay, but if I walk and hold R, as you can see, I'm running. And that's the basic toggle run. And what else? Falling damage. Okay, I move it high. Keep the look at my message box here. As soon as I hit the ramp, wow, I fell. Okay, this is where, and here, this is where we will address the falling damage when we have a character that has health points. And that's all to this script. It's nice, documented, everything. I know the documentation. I will remove them because honestly it's annoying. Okay? But if you guys want it, then you can just simply go to the wiki page and read it, and as I said, there is all versions for it there. Now you may ask, why did I do these string accesses? First, when I come back and take a look, oh hey, I need these inputs and a tag like this. On the other side, if I want something that is different from these, and I have named them, for example, forward, backward, strafe, etc., running, jumping, sliding, then I can just simply change it here. That's the reason. I will come back to this script later when I have a working character system, so that I will make a custom interface for it. I don't like it like this. Later on, not now. The next stuff I want to work on. I want a camera system. I don't like my character stuck like this. Sorry, my camera stuck and I can't do anything with my camera here. Okay, I can move the character. I can't rotate the character, and my camera is not working at all. So, what do we need for the camera? First of all, I will create a folder here and call it helpers, and in here I will add alt insert a class, call it helper, and bam, I don't need namespaces. Okay, this class, public static class helper. Okay, I need some using on top. Using system. Using system.collection.generic. I won't use them right now, but I would like to have these here. So using system.blink, and using system.text, and the last one is of course using Unity engine. This one I will need. Okay. Now in helper class, I want a public static, a method that turns back float, and call it clamp angle. It gets a float that says angle, another float for min, and another float for max. Now we say while angle is less than negative 360 or angle is greater than 360. We say if angle is greater than 360, we simply say angle minus equals 360, and if angle is less than minus 360, we add angle plus equals 360. After that, we say return mathf dot clamp angle min and max. Okay. Why do I have an error indication here? Okay. Now another script that I will add is of course the RPG camera. So another folder here. Camera. And another class and call it RPG camera. Of course, no namespaces, please. And RPG camera is inherited from nothing, I think. Oh yeah, sorry, it's from mono behavior, and it ReSharper adds for me Unity engine. Okay. Another thing that I need is using system dot security dot cryptography dot x509 yeah, certificate. Thank you. The other one is using system dot collections. Okay. Now I like this way. I will say system dot serializable public class RPG camera settings. Okay. And then another one. C, Control E, but this guy is RPG camera axes. And here I will add component menu, call it RPG slash camera slash TPS for third person camera. Okay. Now for settings, public float distance. By the way, lots of this camera system comes from 3D Buzz third-person camera system. So if you don't understand it, just go and watch that video. It's free. Public float distance max equals to 30f. Public float mouse speed equals to 8f, and public float mouse scroll equals to 15f. Public float mouse smoothing factor equals to 0.08f. Public float camera distance speed equals to 0.7f. Public float, what else? Camera bottom distance equals to 1f. Public float first person threshold equals to 0.8f. Public float character fade threshold equals to 1.8f. Then public float normal FOV equals 60f. Public float sprinting FOV equals to 75f. And public float FOV damping time equals to 3f. And final one, public string player tag equals to player. Okay. Axis. Public string mouse x equals to mouse x. Public string mouse y equals to mouse y. Public string mouse wheel equals to mouse scroll wheel. The last one, public string horizontal equals to horizontal. Okay. Did that spell it correctly? Yeah. Okay. Now for the camera system. The first things we need is public transform camera. I call it pivot, well, whatever. Then public array of game objects, call it player mesh, and then public. Now RPG camera settings, call it settings, and public RPG camera axis, call it axis. Okay. Now I define a region to make my life easier. Private and static. And the region. Here I will say public static RPG camera. Call it instance. Then I will say vector3. It's private. Vector3 and call it desired position. Another one, private float, desired distance, private float, last distance, and private float, mouse X, private float, mouse X smooth, equals to 0, equals to 0. Then float mouse X velocity, private float mouse Y equals to 0, private float mouse Y smooth equals to 0, and private float mouse Y velocity, then private float mouse Y min equals to negative 89.5 f, private float mouse Y max equals to 89.5 f. Then private float distance velocity, and finally two booleans. Yeah, come on. IntelliSense bool can bottom, and private bool constraint. Yep. Okay. Then some private statics. Private static float half field of view. Private static. Whoa. Static, I said. Float plan aspect. Private static float half plan height, and another one the same, just it's white or width. Okay, close the region. Thank you. Now in void awake. All I'm doing this is saying instance equals this. Yeah, what's the hell? Instance did I just spell it wrong? Instance equals to this. Okay. In the start method, we say settings dot distance equals to mathf dot clamp, and here we say settings dot distance with the minimum of 0.0 f and maximum of settings dot distance max. Okay. Then we say desired distance equals to settings dot distance. Next one. Come on. Half field of view equals to camera dot main camera, or main, it's new, dot field of view divided by 2 multiplies by mathf deg to rad. So we are changing to radian instead of degrees. Then we say plan aspect equals to camera dot main dot aspects. Then we say half plan height equals to camera dot main, camera dot main dot near clip plan multiplies by mathf dot tangent of half field of view, and then we say half width equals to half height multiplied by plan aspect. Then mouse x equals to 0, mouse y equals to 15. Okay. Now, void, of course, late update, because everything related to camera goes in late update. In late update, we say if camera pivot is equal to null, then we do debug.log error, and that's no camera pivot found. And we simply return. Else, we do some stuff. First of all, get input. These are methods. The next one, get desired position. Then get desired, no, sorry. Position update. And then character fade. Okay. I think I missed something. No, I didn't miss something. Okay. Now, first of all, get input. It's void. And we say if settings that distance is greater than 0.1. We say debug.draw line transform position to transform position minus vector 3 up multiplies by settings dot camera button distance and the color dot green. Then we say camera button equals to physics dot line cast from transform dot position to transform dot position minus vector 3 dot up multiply by settings dot camera button distance. Okay. After that, we say bool constraint mouse y equals to cam button and transform dot position dot y minus camera oh come on camera camera finally pivot transform that position y less than equal to 0. Oof. Then we say if can't type input that get mouse button 0 or input that get mouse button 1. So left or right click. We say screen dot show cursor equals to false. Mouse X plus equal to input dot get axis axes dot mouse X multiply by settings dot mouse speed. Then we check if constraint mouse Y. Then we do another if input dot get axis what the hell get axis and the axis we want is axes dot mouse Y. If that is less than 0, then we say mouse Y minus equal to input dot get axis, axes dot mouse y, of course multiply by settings dot mouse speed. Else, no, not here, sorry, here, else we say mouse y minus equal to input dot get axis, axes of mouse y, again multiplies by setting dot mouse speed, and we don't need brackets here. Okay, so if we are not hitting any of these two buttons, else, the only thing we do is screen dot show cursor equals to. After that, we say mouse y equals to helper dot clamp angle with mouse y and the minimum of, I have two constants here, I think I can use it somewhere, please, mouse y mean, comma, mouse y max. After that, we say mouse x, what the hell, did I forgot to put it here? Mouse. Okay. Mouse x smooth equals to mathf dot smooth damp from mouse x smooth to mouse x with a reference of mouse x velocity and its settings dot mouse smoothing factor. Same thing goes for mouse y. Mouse y smooth, mouse y, mouse y, and mouse smooth factor. After that, we say if constraint mouse y, then we say mouse y min equals to mouse y, else mouse y min equals to negative 89.5f again. Then we say mouse y smooth equals to helper dot clamp angle between mouse y smooth and mouse y min and mouse y max. Then we check if input dot get mouse button 1, we say RPG player motor, and I think I forgot something here. Yeah. Okay. We say public static RPG player motor instance in void awake. We say instance equals to this. That's simple. that instance, that transform, that rotation equals to no, quaternion dot Euler with RPG player motor instance dot transform dot Euler angles dot x, and we need the same thing for z, and this is z in between the y. Yeah, what I'm doing. Phew, I can't. Okay. Oh, here we can say camera main dot transform dot Euler angles dot y. Okay, so we are orienting. Why don't my up and down and any of the mouse back? Okay, now it's working. And after that, I think I can remove this guy. Yeah. After that, we say desired distance equals to desired distance minus input dot get axis. Of course, again, axis is dot mouse wheel multiplies by settings dot mouse scroll. So we are moving inside or outside toward the character. If desired distance is greater than settings dot distance max, then we say desired distance equals to settings dot distance max. Otherwise, if desired distance is less than 0.05 f, then we say desired distance equals to 0.005 f. Okay, and that's it. Get desired position. And I want it to be below, so I'm holding Control, Alt, Shift, and up and down arrows. Okay. Here we say settings dot distance equals to desired distance. Then we say desired position equals to get camera position, and it's another method that we say mouse below Y smooth. Yeah, it's flipped. Mouse X smooth and settings dot distance. Then we say float closest distance, and we say constraints equals to false. Then we say closest distance equals to check camera clip plane, another method that we need to add, camera pivot dot position and our desired position. After that, we say if closest distance does not equal to -1, we say settings dot distance equals to closest distance, and then we say desired position again equals to get get camera position, and that's again mouse Y smooth, mouse X smooth, and settings that distance, and then we say constraint equals to true. Lots of jumping around, I know, but that's base system. If you want to see what's going on, again, I highly recommend you to watch the 3D bus system. Then, if last distance, oh no, I forgot something here. It says settings dot distance minus equals to camera main dot near quick plan. I would say if last distance is less than settings dot distance, or we are not constrained. We say settings dot distance equals to mathf dot smooth damp from last distance to settings dot distance. We are referencing the distance velocity, and we use the speed of settings dot camera distance speed. After that, we say if settings dot distance is less than 0.05 f, we want to make it equals to 0.05 f. Then last distance equals to this distance, and desired position equals to get camera position from mouse Y smooth, mouse X smooth, and again our distance. Remember, if the camera view is blocked, this is the new forced position for our camera. Okay. After this method, we need to update our position. Update position is easy, it's really easy. You just say transform that position equals to desired position, and we check if our distance is greater than again 0.05 f. Then we say transform that look at camera pivot, because if we are less than this guy, then we are basically in first person view mode, and we don't want to rotate the camera to look at itself, at the character. Now the last method here is saying that nothing too complicated. We say if player models, player meshes, the length equals to 0, it means that our player does not have any mesh that we want to fade, so we return. Then we say if settings distance is less than settings dot first person threshold, we are going for each. The collection is player meshes. We use variables and we say player mesh. What we want to do is say player mesh dot renderer dot material dot enabled equals to false. Okay. Else if the distance is less than settings dot character fade threshold. Here we want to fade the character, so we say float character alpha equals to 1 minus settings dot character fade threshold minus distance divided by settings dot character fade threshold minus settings dot first person threshold. So we are getting a percentage there. Then we say for each, again, player mesh variable, and we call it player mesh. What we do is that player mesh render enabled equals true, and if player mesh render material color alpha does not equal to our character calculated alpha, then we say player mesh dot render dot what is it material dot color equals new color, and we want all of that. That's red, green, blue, and finally here we say character alpha. Okay, and I hate it when it does this. Now after that, here we say else, so we are outside of the scope of fading. We just copy this and paste it, but instead of character alpha we say 1, so we are fading, we are making it back to the normal. Now that is the bulk of it, but here we have some methods that we need to implement. So It's vector. It's yeah, returning vector3 float. I call it x axis. Another float, y axis. Another float, and I call it distance. And I want to move it down, down. Here we say vector3 offset equals to new vector3 0, comma 0, comma minus distance. Then we say quaternion rotation equals to quaternion dot Euler x-axis comma y-axis if it shows it comma 0, and then we say return camera pivot dot position plus rotation multiplied by offset. Now, before going for the camera clip plan check, we need to add some structures here. So we say public structure clip plane vertices, and we say public vector3 come on, upper left, upper right, lower left, and lower right. After that, I will add the method. So it's returning float vector3. We call it from 3 and 2. Okay. We say var closest distance equals to -1f, and we say ray cast hit info. Then we say clip plan vertices. Clip plan equals to get clip plan add, and we call it 2. This is another method that we need to add, but then we say debug draw line clip plan upper left to clip plan dot upper right, then debug draw line from clip plan dot upper right to clip plan dot lower right, debug dot draw line from clip plan dot lower right 2, click plan to lower left, and finally debug the draw line from click plan dot lower left to click plan dot upper left. Okay, another line debug dot draw line from to 2 with color dot red. Okay, what I'm doing right now is just drawing some debugging lines to show you guys what will happen. Now another debug dot draw line. Now let me copy paste it. It's useless after all. It's not something critical. There we go. Half plan white. Did I miss it? I think I just... yeah. Misspelling. There we go. And what's here? Upper right. What's the problem with that? Oh, double T. So what I'm doing now, I'm just moving away from the camera and doing another clip plan uh, showing with the debug method. Now, for the actual thing, say if physics that line cast from to 2 with outputting to its info. If we hit something and hit info that collider, the tag does not equal to settings dot player tag. So if you are colliding with something other than the player, we say closest distance equals to hit info the distance minus camera main dot near clip plan. Then we check if physics, again a line cast, but this time we go from origin minus transform dot right multiplied by half plan white plus transform dot up multiplied by again half plan, this time height, to clip plan dot upper left and casting it into info and its info dot again collider dot tag does not equal to settings dot player tag. We check something's wrong here. It's plus I said, okay. We check if hit info the distance is less than closest distance or closest distance is equal to -1. Then we'd say closest distance equals to vector 3. That distance between hit info dot point plus transform, come on, dot up. Oh, that's right. It's getting confusing even for myself. Oof. Half plan white minus transform dot up multiplied by half plan white and from. And is it plus? Yeah. Okay. Same sequence happens many more times, at least 3 more times. So I just copy it and paste it. This time we go to right and up and checking the same thing. But then if we hit, we want to move to left. Okay. This time we are moving to left and we are checking down instead. So here we plus to up. Last time we are checking the right and down. So minus. So if it's something, then we want to move to left and up. Phew! Finally, we return closest distance. This part is completely explained in 3D Buzz video. I don't go over it. The last thing that we need is this guy. And I just need to do this. Vector 3, and this is position. We say var, not car. Clip plan equals to new clip plan vertices. Okay, so we are defining a structure there. Then we check if camera.main is exist, because if we don't have anything, we just return this clip plan as a null object, or as actually 0 vector trees. Then we say transform equals to camera dot main dot transform. After that, we say float offset equals to camera dot main dot near clip plan. Now we say clip plan dot upper left equals to our position given to him minus transform that's right multiplied by half plan byte. So we are defining each point. Then we say click plan dot, again, upper left plus equal to transform dot up multiplied by half plan height, and click plan dot upper left plus equal to transform dot forward multiplied by offset. Okay, we need to do it 3 more times, and this time we are going for upper right. So upper right is of course to the right side, and upper, then we want it to, no, this guy, thank you. We want to go for lower left, so it will be lower left, and of course we are going to left, and we are going to be on low. Yeah, and the last time we are going for lower right. So we are going toward the right and toward the downside, and after all of that we return again the click plan. Oh, now the functionality of the camera system is done, believe it or not. But I like to add a little method here. As you can see, we don't have any errors. It's green on the lower right side. The method I will add has nothing to do with the camera movement at all, but I want to have it, and that is public void, and that is camera setup. And we say game object camera used, another game object that is camera pivot, and RPG camera called camera script. Then we check if camera dot main does not equal to null, means we have it. Then we say camera used equals to camera dot main dot game object. Else, it means that we don't have any camera, any main camera. We say camera used equals to new game object, and we call it main camera. Then we say camera used dot add component. The component we will add is camera, and then camera used dot tag equals to main camera, and this tag is the thing that defines the camera as the main camera in the game. Now we say if not camera used dot get component, RPG camera. So if you don't have the component in the camera, you say camera used dot add component RPG camera. Then we say camera script. Where are you? Camera script equals to camera used dot get component, and this is RPG camera. Okay. Now, after that, we say if camera pivot equals to null, then we say the lowercase camera pivot equals to game object. I don't like what I'm doing here, but meh. Camera pivot, and we return it as game object. At the end, you're saying camera script dot camera pivot equals to camera pivot with lowercase dot transform. Okay, but there is a possibility that this guy sends us null. So I need to check if camera pivot equals to null, then I will make camera pivot equals to new game object with the name of camera pivot. Then I say lots of sounds, camera pivot dot transform position equals to I can make it two ways. I think I will do RPG player motor dot instance dot game object dot transform dot position multiplies by new. No, multiplies by no. Okay, I can't do it like that. We say new vector tree, and I just control C dot X dot Y, but +1, and dot Z, and then we have it. Okay, but then I need to say camera pivot transform pant equals to g motor instance game object transform. There. Now, finally, this is done. Main camera. Okay, main camera. Add component RPG camera TPS. And as you can see, I don't have any camera pivot, and my capsule has no game object. As soon as I run it, nothing will happen. Okay? That's because I didn't call this method anywhere, and I like to call it right at the start before everything else. So now if I run, let's say the camera pivot, here is the camera pivot right on top of the player's head, and as you can see, whoa, I can move around, I can, yeah, this is interesting. I should mention it before anything else. As you can see, I should change that nose. I don't like that nose. Cube frame. Um, what to do? Oh well, I just move it right. Okay. Then again, rotate it a bit because I want to have some sort of indication. Anyway, okay. There. Now, if you notice, when I'm using the right mouse button, the character is rotating with the camera. If I use the left mouse button, I can freely rotate around. But then, as soon as, bam, I hit the right mouse button, the character will rotate and uh, align itself. Now, if I move the camera so that I don't see the player, our camera comes out of it, okay? Now, this is good and all dandy. I want to make something interesting. Game object. Create other, please. Cube. Thank you. W down. Or I'm making a wall. And move it away from the character. And make sure that's okay. Now, I have a way to move the character around. And here we go. Now, keep looking, and voila! Here our character should be completely faded, but it doesn't. Why? You guessed, because I didn't assign any player meshes to this guy. So for that, I will assign number 2, and this is one of them, and the nose is another one, and here I need to assign the tag of player to this guy. Of course, the child needs to be tagged as player 2. Okay. Now if I play, if I'm moving closer, whoop, the character fades away. Here we go. You can see it completely easily here. Now, this is the debugging lines I was showing. This is your clip plan, okay? And these are the calculations, these cyan lines are the calculations that we are doing to see if we are occluded or not. This is the position of the camera at the origin. And if I move it around, you see the camera goes back to that point. If I go to the wall, oops, the camera comes nearer and nearer to the character, as you can see, until I hit a point that I will penetrate the character right here, and the character fades away. So now I'm again in not first person mode, not really, but you know, you can have it. And as soon as you get outside of the clipping, you see the camera comes back, for example here, and you see the camera sticks to the wall, and I am free from the restrictions. So if I move, for example, somewhere here, and move the camera around. Bam. I'm occluded. I'm occluded. Now, if I want to do it with the camera again, it's the same thing. It's the same stuff. As you can see. Okay. So we have our camera system. We have our base character system. In next episode, I will start with character mechanism animations. But before that, I will import a very handy, very useful script, because as you know, as you may notice, if I play the game now, the camera, everything is following, but the scene, hey, where is my player? Oh, it's here. Come on, zoom, and then I move it, zoom, 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 zoom. Okay, I'm good. I can see everything I want. But as soon as I do this, oh, come on, I need it again. I don't like it. There is a script, very nice script there, that helps you to keep this scene focused on the things that it's seeing right at the start of the game. I will import it next episode. But that's all to this episode. I hope you liked it. If it was a bit confusing, please go back and watch the 3D Boss third-person camera system for the camera calculations and what they are doing there. Even the character moving system is uh, more understandable if you watch those series. That series is a bit old, using the old animation system. I will replace it with Mechanim here in next episodes. So have fun, everybody. Bye bye.